In this video, you'll learn how to solve problems on solubility product as a continuation of a series on the solutions to Chemistry Olympiad questions. But before then, I am Charles, the Science Chef, creator of the Science Chef Academy YouTube channel, your online STEM study room where you can learn, grow, and succeed in any of your science, technology, engineering, and mathematics subjects. Calculate the solubility of lead sulfate, PbSO4, at 25 degrees Celsius in distilled water. At 25 degrees Celsius, PbSO4 has a solubility product of 1.3 times 10 raised to the power 8 molar squared. When solid PbO4 dissolves initially, the system contains only PbSO4 and water. However, as time passes, lead sulfate will dissolve until lead ions and sulfate ions reach equilibrium concentration and the solution becomes saturated. This question is on solubility product, but here we are asked to calculate the solubility of lead sulfate, that's PbSO4. So what is solubility product? Solubility product is the product of the active masses of the ions of a sparingly soluble salt present in its saturated solution at constant temperature or at a given temperature. It's just like equilibrium constant, except that in this case it is not a ratio because it only applies to ionic compounds that are sparingly soluble. So when we have questions like, the first thing we need to do is to write out the dissociation equation for the sparingly soluble word salt, which will be PbSO4, in this case solid, giving us Pb2 plus aqueous plus SO42 minus aqueous. Then what's the mole ratio here? The mole ratio here is 1:1. Just like equilibrium constant expression, we can write the solubility product expression for this salt, which will be Ksp equals to the active mass of the lead 2 ion raised to the power 1 times the active mass of the SO42 minus sulfate ion raised to the power 1. Right. So what are we told to find? We are told to find the solubility of the lead 2 sulfate. Right. And to find the solubility of this lead 2 sulfate, we need to know the solubility of the lead 2 ion and the sulfate ion in solution. So we can select the solubility of PbSO4, lead 2 sulfate, be equal to what? X. Now from the equation of reaction, the number of moles of PbSO4 is equal to the number of moles of Pb2 plus. It's also equal to the number of moles of NSO42 minus. This implies that the solubility of Pb2 plus can also be taken to be what? X. If you apply this variable into this equation, you can say that the Ksp, that's solubility product of lead 2 sulfate, will be equal to what? X squared. That's X times X, right? But we are told that the value of the Ksp at 25 degrees Celsius given is what? 1.3 times 10 raised to the power 8 molar squared. That's 1.3 times 10 raised to the power 8 molar squared, which is the same thing as 1.3 times 10 raised to the power 8 mole squared per dm raised to the power 6. So from this expression, we can see that X will be equal to what? The square root of the Ksp of the salt. So if you substitute the values, that will be X equals to the square root of 1.3 times 10 raised to the power 8 mole squared per dm raised to power what 6, and if we evaluate this, you get 1.14 times 10 raised to power 4 mole per dm cube, which is equal to 1.14 times 10 raised to power 4 molar. So since X is the concentration of Pb2 plus, that's lead 2 ion, and the concentration of lead 2 ion is the same as the concentration of the lead 2 sulfate based on the equation of reaction, based on the mole ratio of the equation of reaction, right? So it implies that the solubility of the lead 2 sulfate is 1.14 times 10 raised to power 4 molar. If you are preparing for JAM, then send a message to the number showing on your screen to join our Telegram channel for our JAM intensive classes at a very affordable rate. So if this video was helpful to you, drop a comment and hit the like button. Also, if this is your first time here, subscribe to our channel and turn on your notification bell to always stay updated with our new uploads. Always strive to be a better version of yourself until I see you when I'll see you.